Welcome to my project bazaar.com. Now let's see the title of our project. Content based image retrieval with the graph theoretical approach. This is our title. Let's see the abstract. Nowadays there has been huge number of images available in our real world. So there is a necessity to retrieve the similar image for the query image given by the users, right? So image retrieval will be carried out by various techniques. In our project we're gonna retrieve the images based on the content based image retrieval technique. Okay, first the regions the various regions that are available in the query image given by the users will be well analyzed and determined. Then the histogram of the various regions in the query image will be calculated. The histogram will be calculated based on the colors which is present in the set of regions in the query image. After that, the distance calculation, distance of the every region will be well analyzed and determined. Then the now here we are using the Coral Images database as a here in our project we using Coral dataset Coral Images dataset as a database which is contained 1000 images. So first we user need to user need to provide on input. Here user need to provide a query image for which the similar images from the database need to be retrieved. Okay, after determining the regions histograms as well as calculating distance of the after determining after determining a regions which is present in the query image, the regions need to be segmented. So that is the image segmentation based on the regions will be carried out. After performing the image segmentation, the histogram values of the every regions will be well gathered and determined. After that the distance of the every regions will be well analyzed. Then in our project we are using a Coral Images data set as a database which is contained 1000 images. Here then the images for every images from the database will be carried out by region analyzation and the image segmentation which is already performed as in for the query image So after evaluating the regions and the image segmentation of the every images in the every images in the database, and the regions the histograms of the every regions in the image in the processed image, then the histogram of the regions will be calculated. Then the comparison between the histograms of the query image and the histograms of the images in the database will be carried out, which is then distance of the regions will be well calculated. For calculating distance we are using the Euclidean distance. After determining the regions and the histograms as well as the distance of every regions, the 1000 images in the database will be sorted and will be arranged in order of the after analyzing the regions and the histograms of the histograms as well as the distance of the every 1000 images, then the images will be arranged in order in such a way that the topmost image will be the most accurate image for the input query image which is given by the users. Then the remaining similar images will be arranged according to the most accurate image. The arrangement of the every 1000 images is based on the distance. The topmost image at the most that is the topmost image, that is most accurate image, which will have the most least distance. Okay, after the based on the distance, the based on the distance, the 1000 will images will be arranged in a order. After evaluating the distance and after acquiring the most similar images, after acquiring the most similar images for the input query image, after acquiring the most similar images from the database for the query image given by the client, uh, will be carried out by a graphing method. The graph that shows the time acquired for retrieving the most similar images, and the graph that graph it shows the time acquired by the image for so the graph that shows the time acquired by the images based on the similarity for the input images. Let's see the data flow diagram of our project. Here, as I said, user need to provide some input query image. After providing the query image, the regions that are present available in the query image will be well analyzed. Then the regions will be segmented into different parts based on the colors. After performing the image segmentation, the histograms values of the every regions will be well calculated. After calculating the histograms as well as the after acquiring the histogram values as well as the distance values of the regions, the image comparison between the query image for each image from the database will be carried out. For comparison between the histograms as well as the distance, we will be using the Euclid distance formula for the distance calculation. Then after performing the distance calculation, the 1000 images will be arranged in order in which by which we can so the 1000 images will be arranged in order in which the topmost image will be the most accurate, and the remaining appending images will be the most similar image for the input query image. After acquiring the most similar image from the database, will be carried out by graphing method. So in that graph shows the time acquired by the image based on the similarity for the input query image. Yeah. Now let's see the demo of our project. This is the home screen of our project. Here user need to provide some input query for which the similar images from the database need to be retrieved. Here I am selecting on tensor images as the input image. Let's proceed with this image. Here the list shows the images which is available. Here this list shows the images which are available in the database. Here in our database it will be containing 1063 images. Let's proceed with this. First we need to generate the threshold image by which we can able to see the object which is present in our input images. After generating some threshold images will be carried out by the process. In this image retrieval process, at first as I said first, the image analyzation and the image segmentation will be performed. After the image segmentation, the histogram values of the every regions in the query image as well as the distance of the regions will be well analyzed. After that, for every images in the database, the both same the image segmentation as well as the distance of the regions will be well calculated. Then the comparison between the histograms of the input image as well as the histograms of the images in the database will be performed. During that distance displacement of the regions will be evaluated. For distance calculation we will be using the Euclidean distance. Then after that, based on the distance, we will be getting the most similar images list from the database. It takes some time to retrieve the similar images. This list shows the most similar images. The topmost images will be the most accurate images for the input query image. Remaining images are the most similar image for the query image. The similar images will be similar image list will be retrieved, which is based on the distance. So topmost means that is the most accurate images will have the most least distance. Let's proceed with the image viewer. These are the top 20 images from the database which is similar, most accurate, as well as the similar images for the input query image. Let's proceed with the graph. This graph shows the time acquired for the program to retrieve based on the similarity. This graph shows the top 20 images. Thank you.